Hey, very good day to you. I'm Java guy here at Vox Days Luxembourg, and I have another special guest today. This is Thomas Darimont sitting next to me. Keycloak maintainer,
Exactly.
company founder, leader of JUG Saarland, open source contributor, international speaker, and probably something that I forgot, right, Thomas?
Yeah. I'm a humble guy, by the way. Thank you very much.
Thank you. So, you gave a very nice talk here today at Vox Days Luxembourg about Java and WebAssembly. So, can you tell us in a few sentences what is that about?
Well, the talk was about WebAssembly for Java developers, and WebAssembly is basically a whole set of different technologies. But first of all, it's an intermediate execution format similar to JVM bytecode, but with a more broader scope, which means being able to execute logic not only on the JVM, but on every platform that is out there that provides a runtime that can execute.
Yeah. So, the target platform doesn't have to have JVM installed
exactly
to run code that is compiled to WebAssembly.
Exactly. But the target platform needs to have a WebAssembly runtime. There are many different WebAssembly runtimes available for a multitude of different platforms. And there are also projects that allow you to embed a WebAssembly runtime in your application, be it a Java application, a .NET application, a Python app, a Rust app, a Go app, whatever.
Yeah, excellent. And that allows us to have some very interesting capabilities. For example, we can execute our Java code, so compile it to WebAssembly, and then execute it as Lambda functions, for example.
There are projects that allow that, but usually the use case, the more prominent use case is in the context of Java applications, the other way around. You will basically have your Java application and have it execute WebAssembly workload that is was initially written in a different language than Java. That was then compiled down to WebAssembly, and then you use an embedded WebAssembly runtime in Java to basically execute that workload with some data out of your application. And when the WebAssembly workload produces some output, you read that back and translate it into your application objects as usual. And one cool thing that I demonstrated was that some runtimes also allows you to specify callback functions, more or less, that allows your WebAssembly workload to call back into your Java application to invoke certain functionality.
Excellent. So I would say that's polyglot programming at its best.
Exactly.
Right. So I also had an impression that this is very quickly developing technology. Maybe it's not ready for prime time yet.
That's for sure. WebAssembly support on the JVM is, at most, in my opinion, still at its infancy, but it's developing rapidly and evolving quickly. As you have seen in my talk, I showed also all sort of simple examples, like where you execute WebAssembly workload that adds two numbers, so on. But you can do much more sophisticated stuff already. You can, depending on the capabilities of the WebAssembly runtime, you can execute network calls from WebAssembly. You can do HTTP calls. You can call out in Java code. And as part of the demos, I even showed you that the current implementations of runtimes available for Java are even already powerful enough to run Doom on the JVM without using any native libraries, which is quite impressive, I think.
Yeah, and I confirm it is. So I've seen it personally, JVM running Doom without any other library. So that's very promising.
That's cool. Yeah.
Excellent. So would you say for developers that are senior or near senior level, does it make sense for them to investigate more this WebAssembly technology and its interoperability with JVM?
In my opinion, it's of course a technology that you should really take a look into, especially with in the context of using it as a mechanism for supporting plugin mechanisms. Like, as you know, if you want to make your Java application extensible, we usually provide a Java-based API for that our consumers then implement and provide implementations and so on. that's all nice and good and works for many decades already. However, it is often very hard to restrict what these plugins can do in the end, because in the end it's just JVM bytecode that runs on the Java virtual machine, and it can basically do everything what the system allows, more or less. Yeah, and sometimes you might need to have more capabilities. You need to have more support for restricting what the plugin can do. And that's exactly where the WebAssembly runtimes come into play, which provides an interesting sandboxing model that allows you to restrict what kind of functionality can WebAssembly workload actually execute on the JVM and use. And you can limit the memory that is used by the WebAssembly workload, as well as the execution time, or even the amount of instructions that the workload can execute can be limited, which helps you to avoid all kinds of security issues like infinite loops in untrusted code and so on. And also, you can control the capabilities that you give the WebAssembly workload, like whether you allow file system access, network access, or high-level APIs like HTTP requests and so on. And this is quite powerful capability to have for this kind of problem domain of a plugin system, for instance.
Excellent. So, Thomas, thank you so much for these insights about JVM and WebAssembly, and enjoy Voxy Days.
Yeah, you too. Thank you very much.
Thank you.
Bye.
See you.